weeks in, I still haven't got it right. Okay, we'll start again since I forgot to record. So the plan of action today is that I want to cover 4 things with you guys, as I mentioned there in the Slack channel. I want to mention some things that I noticed as I was doing it offline, and that things that I would want to just make flag with you guys. And they're kind of things that I imagine would have come up in a lab if I was in the room physically with you guys, and you'd just ask me the question, "Hey, what's happening here?" So, given the fact we're not physically in the room and we're probably slower to ask online, I just actually want to mention a few of them now. The second thing is to talk about ensemble models. And the third thing is to talk about one of the advantages of using an ensemble model. You can actually get a measure of feature importance. And I just want to show you how you can do that. And I say I like to do that because it gives me a sanity check that my features are doing what I want. The other thing then is the hyperparameter training is really, really bloody slow. So you don't want to do that too often. So what I want to do is I want to show you what I would do to minimize the number of times I'm going to use that hyperparameter training. And the last point there is actually what metric we're going to use. Okay, so let's actually just start running through it. And the gotchas, so there's 2 gotchas I wanted to talk to you about. If you look, and so I'll start sharing the screen and we'll start going through them. All right, so if you look, so what do so at this stage, if you guys have done all the stuff that we did yesterday, you now, when you run your model, at the very end of it, you're generating a zip file. So at the very end of it, you run something like this, and it's going to generate a zip file. And if you look inside in your inside, and I'll open it from here, so it's just easy. You should have a zip file in there called mylib.zip. And if you look inside, and that should have the files that I actually gave you here, those 4. Your 3 notebooks, the Python script file, and your generated predictions. And so if you upload that file to Moodle, I'll put the link in Moodle, I haven't done it yet. On Saturday, by Saturday night, on Sunday, all I'm going to do is download those, evaluate your predictions, and store in Moodle how good your predictions were. Okay. And the idea would be then is when you later upload the final one, it'll be that on that basis that some of your marks will be going towards. Okay, assuming you got that down to there, now we need to look back at this model. I did all the stuff we have here. Currently, the model we are using is really basic when we want to improve it. But if you're using hyper training parameters, it's very, very slow. So we want to see about getting that faster. Okay, so let's actually go back to where we're at. First thing, actually, so the list of the 4 things I gave you, the gotchas. When I started adding the various features, as we were doing with you guys yesterday, I added, we already had type of mission and source of admission. When you started adding the others like patient state and so on and so forth. And this is pretty much where we got to where we started off yesterday. Then I said, okay, what we're going to do is we keep running through, or what you're going to do is you're going to keep running through your document, the user document, and you're going to keep adding on your features. So one of the features I added on yesterday was patient country. So it's only that I realized it this morning when I was talking to one of you guys on one-on-one, is that if I look at the feature patient country, sorry, apologies, it's 18, gone too far, back 18. And that, where is it? Not 18, it's feature, back here, feature 14. Then what happens here is this, is that, what did I do? I looked at it, and we saw we had a number of categories. Predominantly, they were all, so if I look at my EDA for that, and you can see it is this guy here. And what I have found is that, hey, practically everybody is from the US, and there's a number that are not known. And then there's so many from Mexico, and then the rest is from a whole lot of other countries. And what I do with you guys was say, excuse me, what we should do is start merge all of these guys, these rare ones together. Because it's only one. That's only one out of, what is it, 50,000. So it's way too small to be being used. So you merge those. And the way I said to merge them is, hey, you should use your is-in. That's fine. And it works as long as I can list all my possibilities here. The problem is when I run this, if I go back up to the very, very top, currently I'm only running it on 1/20th of my data set. What happens when I run it with, say, half of my data set? Or if I run it with all of my data set, like that. Remember the naming convention we have up here? And what's going to happen? Well, when I run that with more and more of my data, I'd expect I'm going to get more entries here. So I want a piece of code here that is robust, that deals with me getting a new category here, and encodes it properly. So a change I would want to make to what I said to you yesterday is this, is the way I looked at it is this. I have a category US that I want to keep. I have a category MX for Mexico that I want to keep because I imagine that's going to be pretty big. And then I want a category NA for, sorry, then I want to, what else do I want? I want a category US, I want a category Mexico, I want a category for not a number, NA or whatever I want to call it, for that. And all the rest of the stuff, all the rest of the guys, of the things, I'm going to expect to be very small, and I'm just going to group them all together, and I'm going to give it some code that I'm going to treat as being another country. So how do I do that? I use as-in as before, but what I do is I do it in reverse. Sorry, yeah, sorry. Hold on a second now. Let me ask me a question on Slack. One second, guys. Okay, it's only grand. I thought. Okay. So where was I saying? Yeah. So the way I would do it is this: is that I have my three categories I know I'm going to have: US, Mexico, and NA. And then what I do is I use as-in, and I use a not in front of it here. So that basically means that any rows where the patient country is not one of those three things, I'm going to replace it by XX. Okay, and so because I would imagine any category that's not one of those three is going to be small, and I'm lumping all those guys together. If later on I find that it's not, then I'll come back and I'll review this. And that's one of the things I wanted to say to you as well on this. If I write this as the pattern of me writing this to EDA document, like the way I'm writing it down here, the advantage of writing it this way is that I can go back up to the very top. Once I'm doing it on a small data set, I can go up to the very, very top up here, and I can actually then change this to run on the entire data set. And all I would do then is this, is I'd put it to the entire data set, I go and click, I would reset kernel, and run all cells. And what I do is I go off and get a cup of coffee, okay, and wait till it finishes. And did it just run? You hardly ran. Oh yeah, it's running now. Now the EDA is relatively fast, but as you add more and more columns, it get down. So all I do is let it run and see what actually happens. But I'd only do that near the end, and I just want to make sure it's running right. Okay. So at the moment it's running way down, blah, 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 all the way down to the end. And when it comes to the end, we'll see. And just say why. I see, sorry, I have it above here. I'll hear a message when it's done. Other than that, the only change I made to the code here is you can see here in the code. I had encode labels which took out the first character of my line to encode it, and then I always had another function, encode labels, which took the first two characters out of my line to encode it. And as I was saying to you yesterday, they're kind of sloppy. I wrote them because it's the first thing that came to mind, but it wasn't the best solution. A better solution is to split my label up based on where my space is. So I've got two functions here which do that. And all I do is I apply it to all my stuff all the way down. So, okay, every time I get a feature I want to keep, I just encode it. One of the things I do with the encoding is this, just to make it easier for me later on. That quote, I don't like that quote being in my feature names. So if you see in when I actually change my feature, when I'm changing my categories later on, I tend to always recode that to be something else. Okay. All right. So that's the gotcha I wanted to have here. Be careful of a feature like patient country, which effectively could be open-ended in the number of categories it has. And so instead of prescribing what should happen at each individual category, you should basically do like I've done here, and do the reverse operation. Yeah, so my EDA is done now, and so I just ran it. It's now gone on to the very, very end, and all I would do then is I just quickly scan each of these things as I go down to see, has anything weird happened in terms of my categories? Have I suddenly got next to category that I didn't think it was there before? All right. Other than that, one other thing we talked about yesterday is I was wondering about the difference between race and ethnicity. So this is the chart I have here after doing a cross tab of the two of those guys. And I look at it and I honestly, sorry, not one, no, not there. This is the chart I wanted to point at. I apologize. And looking at that, I'm not really too sure what exactly is the difference in the two of them. They didn't, or what exactly do people mean when they want to go one specific race versus ethnicity? Are they referring to that one of their parents or their grandparents are from a various ethnic group or not? I don't know. So my view would be is I'd be keeping both those two features in, because they seem to, if I look at it, ethnicity, I mean, it's, you're not Hispanic region majority if you're American Indian, you're predominantly not if you're Asian or Pacific, you're not if you're predominantly black, you're not if you're predominantly white, but other is predominantly being of Hispanic origin. But the breakdown isn't complete. So yeah, so most Hispanics are into other, are in terms of race. So I would keep both features is basically what I'm doing, and see what happens. All right. Other than that, and so the rest of the features then you can do yourself. I've removed them from my code here because I don't want you to. I'm showing too much of this code as it is. Okay, so that's the gotcha I have here. The second gotcha I want to talk about is that when you bring in your categories and include them into here, remember this function we have of building them all up, and they always have a careful look at the output you generate down here to make sure it actually is doing it's actually doing the mapping that you actually want. And in particular, if you go down further, when you do the labeling of your columns, print out your columns. If I, for example, here include a new column, let's go include the ethnicity one. So I'm including the ethnicity one here. There's it now included. So I'm running that. Now this is my columns before, and now I'm going to update it. So at the moment I'm going to go down as far as race and run it now. It also includes my ethnicity. And if you look then, always just keep an eye on these columns, because now if I look down here at my ethnicity, I have in here, I have a column name called that. So it has the quote in it. Okay. And I also have a column name called this. So in other words, it's encoded my missing values I have for ethnicity. So the comment I'd have would be is that whenever I see something like that, it basically means I've forgotten to go up here to my function that I use for cleaning my categories, and I've forgotten to put in my code there for cleaning my ethnicity. So go back, and this is the code I have for cleaning my ethnicity, and so I copy all of it. You notice I've started putting in the field name, the field number in my my code as a comment, just so that it's easy for me to find the bloody things in the document afterwards in the PDF. All right, so now when I run that, I also have my ethnicity, and if I go down then and encode my categories, now rather than having ethnicity in and now having the backslash, I now have ethnicity 1, 2, and NA, which is the string I use to replace NANs. So lowercase NAN basically means it actually is encoded the missing value, as opposed to actually doing what it's done there, where I replaced the missing value by the string in A. Okay, so that's what is the list of the 4 things I want to talk to you about, and keep conscious of time, because I said I promised I wouldn't talk for 2 hours. I noticed the YouTube videos, the number of views, the hour-long lectures, there was a good few people watching it. The 2-hour-long lecture, very few of you watched it, and I understand. Okay, using ensemble models. We've talked about them in class. All they are is, rather than you using a single model to fit your data, you can use a whole lot of them, and then you're actually going to combine them in some way to get to get majority voters which one to pick. So I decided to. So we're going to. So this is an example of one being used. So you use them exactly the same way as using normal models. So I decided to pick just one that you may not have seen before, in order to encourage you to look up in your list of ensemble models to see what ones are there. So the one I decided to pick is Extra-Tree Classifier. What Extra-Tree Classifier does, and all I do is I actually fit it down, I include it down here. And actually, I'll get rid of that thing for the moment. I'm sorry, I'll talk about that thing in quotes in a moment. So what Extra-Tree actually does is basically it takes your data, takes a subset of your data, and you can specify it by either doing it by using the bootstrap method or not using the bootstrap method. And for the subset of data it generates a model, it generates a decision tree. So basically, it generates, a single decision tree, and it repeats that based on a number of estimators you pass in. And then what it does is it takes all of those in this case 250 different decision trees, and it uses an average of those to decide whether hey, which class something should be in. Okay, so that's basically the idea. And so it's slower because it's basically 250 decision trees being run. Okay, and so what have I done? So to use it is pretty easy. Just import it as normal and run it. I've got rid of these 2 guys. And the reason why I've commented these two guys out is that these k-nearest neighbors and support vector is that, especially the support vector one, that the training of that gets slower and slower and slower as the data set gets bigger. And I wasn't doing that well anyway, so I just cut it out. Okay, and then just keeping logistic regression in there because hey, it's an easy one to have, and it's also it's kind of acting like the that's kind of word. It's kind of I'm leaving in here so it kind of stops groupthink, and because these guys are all decision trees and this guy up here isn't, so I'm trying to see, hey, will it do something different? That's all. But so at the moment I have 3 classifiers. So but what I want to talk to you today about is what happens if I use an ensemble method. What can I do? So that's that stuff in there. And you know, anybody who was eagle-eyed, and then 1 or 2 of you had been already, every time I give you these notes, I'm giving you a different metric, all right? And I'm not at all happy with any of the standard metrics. And the one I'm currently least unhappy with is the recall metric. So at the end of this thing, when I get to point 4, I'll fix a metric with you guys. So excuse me. So here I'm just actually running to my classifiers, and you can see that there's the corresponding score I'm getting for the recall metric. So the decision trees are not performing as well as logistic regression. Logistic regression is just slightly better when I use that as my metric. Okay, but bar part 44. Okay, now why do I want to talk to you about so that's just the same code as I had before. All I've done is change my metric. That's relevant. Here is doing my predictions and just showing a sample of them. And again, you can see in this first case here, for example, logistic regression is predicting a 2, which is a short-term patient. My decision trees are predicting a 1, which is a medium-term patient, but reality is 0, which is a long-term patient. So a metric that says, hey, the 1 is closer to the 0 than the 2 is a metric I'd like to use. But and there are ways of encoding it, but I'm just conscious of time, so yeah, I'll come back to metrics in a second. What I want to talk to you about was the whole idea of feature importance. And we add our features, we want to see which ones are important and what are not. And it's one of the reasons why I have given you this code up here and why we talk through it. This code, why we've done this. There's a way of actually encoding your labels, your features, in a single line using it's a method of the PD of the package itself, the library itself. PD something I can't remember. PD labelize, I think it was called. But I'm making that up there. Instead, we've actually done it with 5 or 6. We've done it by 10 or 15 lines. The reason why we did it this way is that all my features, they're all given names that that make sense. So from these columns here, I can figure out what the hell various things are. It's another reason why I'm not using pipeline. I give a class talking to you guys about pipeline, and pipeline is really nice. But if I decide to use pipeline and I actually use transformations to scale my features, then what I lose is I lose the names of my features. And in this case, I wanted to see, well, what features are important and what are not. So that's why I have the structure I have here. So we can see it now being used. So let's go down to my feature importance. So all I've done here is I just pick one of my models. So and I only have one ensemble method here, so it's going to, my choice is to pick extra tree classifier. All I've done here is from my list of classifiers that I fit up there, I just taken the one I want to talk about, the extra tree classifier, just to make life easier. So CLF now corresponds to my trained extra trees classifier. That's an ensemble method, so it actually has a measurement of how important my various features are. So all I'm doing there is I get back that list from using and store it in the importances. And what the next 2 lines are doing is all I'm doing here is because I have, for each decision tree I've been trained, a measure of importance, I can go off and calculate my standard deviation of my importance. So all it's doing there is running through all my trees I have in my classifier and calculate my standard deviation. And what this is doing here is giving me back my feature positions based on feature importance. So it's giving back my arg sort, gives me back, it's sorting there based on the value of how important my various features are. And what can I use this for? Well, I can do this following loop here. So all I'm doing here is just first capturing all my feature names. So remember, that's the data set I use to do my training in. Okay. All I do is getting back my columns, but I'm getting back my columns in the order based on how important my features are. And so then I can, with a for loop here, I can, so this is it, run it again. This is because I might have done it on a different data set. This is my my list of my features, and it's just saying which features are more important and are most important. So from this, source of admission 4 is the most important. And if you go back to source of admission, that was basically, I think, source of admission is where you transfer from one in the hospital. Okay. And so on. And type of admission 4 then was, I think your newborn. No, yeah, it is newborn. And so you can see and you look at if I look at the actual plots, you can see here, clearly here, number 4 for type of admission, newborn, they clearly were very different from all the rest. So you having the decision tree picking that out is exactly what you'd expect should happen. All right. So I look at the diagram here and say, then this is good. This appears to be spotting the things that we saw ourselves from the EDA, that this row here clearly should be important. And so that's your various chart of them. And you can look at that as you build it up. Down below here, I mean, so that you can take the code from the website, from the video, I imagine. Down here, all I'm doing is doing a plot of it. That's all. So I just made it very tall plot because I wanted to see properly. And all I'm doing is doing horizontal bar plot, and white ticks then are just my actual names, my features. And all I'm doing then is putting a horizontal line there representing my standard deviation. And so the whole idea would be is, excuse me, so you can see there's a fair bit of noise in here in terms of how important the features are. And my standard deviation is nearly as big as how big the actual measurement of how important the feature is in itself, but it isn't. So so currently this feature here, source emission, has this level of importance, but the noise is somewhere in this standard deviation set, we think of it as somewhere in this region. So if we look at all of these features here, all of these features we classify as important. And these features are same with, this is the weekday I'm in, and I'm dropping down to basically whether you're from what's MX is whether I'm from Mexico or not. So I'd keep an eye on this plot as I go along to see, are the features I'm adding, and if I can see from my EDA that they have a vastly different behavior in terms of my classes, then if I have a feature that looks like that, then I'd expect to see to appear quite high up on my list of importance of my features that I have go along down here. That's basically the idea. So that's my feature importance. I can get my feature importance for other classifiers, but the advantage of doing it in an ensemble method is I can actually get a standard deviation because I have multiple estimates of my features importance. So I can get by calculating standard deviation of those, I can get an idea of how variable it is. Okay, so that's basically my feature, getting an idea of my feature importance. And it's really just to make sure, hey, a sanity check. Is the thing I'm fitting, sorry, does the thing I'm fitting, does it still make sense? All right, now finally in terms of metrics, as I said, I'm not happy with this, but we finally have to just shake it off the pot, basically. We have to pick one. So the metric I'm going to use with you guys and expect you to use, and we're going to do a hyperparameter training with respect to, is basically the one I have up here, which is the recall macro one. Okay, the reason I'm picking that is this, is that if I look at look at all the other metrics, they vastly, based on just the data we have here, they vastly underemphasize the importance, the long class. And so this is the only metric that I have when I run that actually gives me a confusing matrix. So that's just confusing matrix. That's just, here's the same confusing matrix, just run by using the confusing matrix function. Here I've done it up using crosstabs because I like the look of it this instead. And what do I want in the confusion matrix? Remember, I want stuff to be, I want stuff on the main diagonal. First row in the first column, second row in second column, third row in third column. They're basically correct predictions. It was long, and I predicted long. It was medium and I predicted medium. It was short and predicted short. So if you have a very good classifier, you want those numbers to be as big as possible and the off diagonal ones to be as small as possible. Well, if we use pretty much any other of the classifiers, any other of the metrics, any of the other metrics, and we find that hey, it works well for short, works okay for medium, but for long, it's the max value isn't max value along that row isn't in that first column. So based on that, and I'm going to use that metric, as I said to you before, the recall macro one above. Okay, so that's basically what I've done. So you can see, but in terms of changing, it's a minor thing to change my string up there. If I want to penalize logistic regression more than my decision trees because it's further wrong, I have to write an own metric for it. And we have enough things to worry about. It's basically like staying healthy and this kind of rubbish. And we won't worry about it now. And we just actually go with that metric and see how well we can do. Okay, so using that metric, so you can see there's my decision tree. There's my confusing matrix done manually or just done by the function. Now the other thing I want to talk to you about is hyperparameter tuning. Hyperparameter tuning is really, really slow. What's it doing? It's trying to find for each of my classifiers what combination of my various settings best suit my data for the metric I'm using. But the idea will be is this, it's slow, but I don't need to run it a whole lot of times. So the way I always do it is this. and at the moment I'm only running here I only ran it here because I started running this at 1:45. I was running late. Is if I run it just for, so at the moment there's my parameters I'm storing for each of my classifiers, and every time I add an extra classifier, I just put my extra parameters down below. And here I just ran it for logistic regression, only logistic regression. Now, previously, what I was used to do with you guys, and I flagged a bit of code change. Previously, what I used to do here is I used to save here I used to do dot best and save my best classifier. I'd save my best classifier here. Sorry, best estimator. I'd save my best estimator here. And I don't want to do that anymore. So if you look at the code that I gave you for this before, and so it's the same code as I did in the credit card data set, and get rid of that there, and all you do is save the classifier, save the result from gradient search directly yourself. The reason why I want to save that is this, is I want to get out of that the actual values of the parameters I need to use. So I run this for logistic regression. The reason I'm running for logistic regression because it's actually the quickest. It takes about 20 minutes on my computer. And extra decision tree classifier takes a lot longer because I have a lot more parameters. Remember how it's going to do. I have 2 options here, 3 here, 3 here, 5 here, 2 here, and 2 here. That's 3 times 2, 6. 6 times 3 is 18 classifiers. 18 times 5 is 100, thereabouts. 100 times 2 is 200. That's going to mean it's going to do 400 fits because I have 400 various combinations of my parameters here. For each of those 400 fits, it's going to do it. I reduce this number from 10 to 5, so at least it'll run sometime. But it's going to do that 5 times. And then when one of those 5 times, it means it's going to be fitting basically, in this case, 200 trees, and here it's going to be 500 trees. So it's a lot of time. So what you do is run it, get it going, running it, and go off and do something else. When it runs and finishes, I get this, okay, which is what we had before. But what I want to do now is I want to take out of that the information that will save me from having to run this a second time. So what do? If I had used best classifier up there, then when I come back down here, model at the moment is the same thing as model at the moment is logistic regression. So just saves me having to type logistic regression in because I keep misspelling it. If I type in there dot best parameters, what I get out of it is what are the parameters it found as a result of that search. And all I do is I take those parameters I have there, and all I do is I run up to the very, very top where I create an instance of my classifiers. Here I am up here. And all I do in here is I put in those settings. So I want C to be 0.1. I want my penalty to be L. I want my solver. I thought I already had set my solver, but I hadn't. I want my solver to be that. So now what I've got is I'm now saved. Something's wrong with that because I can't get rid of codes without fucking things up. I got rid of the second one there for some reason. So I've now got my logistic regression, and I've got it set up with what I think are the optimal parameters. Now, as we add more columns to your data set, as you add more features, your values of your optimal parameters, they will drift. Likely, they will drift a little bit. But the idea will be is that they won't be. They may not drift a whole lot. So what I would do now is this: is that I wouldn't be running my hyperparameter thing again for a very long time. So I'd completely ignore this. So I would be I should have my code set up so that I'd actually just do here break. So it's doing nothing. Or I'd wrap all this stuff in a like an if statement with if false, so it wouldn't be running it. So I'd have none of this code working at all. So that when I run all my ideas, when I run all my stuff in here, I don't want to be running my hyperparameter tuning every time. Okay, and I've now got an idea of what are my good parameters, and I keep those. Okay, so now I have actually so then you just rearrange the code that comes after it a little bit, just so it's all, I mean, I put it into a single cell, and I wrap it in an if statement. So if I have a flag saying run hyperparameter tuning, so I might actually do it like that. Okay, let's go up to the top. Up to the very top, here I have debug, and I might put in another one called HYPER hyper GUNING, and I want to have that to be false. All right, and so I go down, and what I want is when I come down to my hyperparameter tuning, I have that there, and this is the code doing the tuning, and I want to I'd have in here I'd have if hyperparameter tuning. I would do that stuff in here and get rid of that thing now. So now we have an if statement that will only run when I have that thing turned on above. And that's so at the moment when it's turned off, that's all gone. Because I never state random lighting on top. Apologize. Go back down to the bottom again. I've now put that in an if statement, so now that's all saved off. And this thing here, I'm gonna just get rid of that. That's only just me having audible output that it's running. I get rid of this, and I'll put this code. I can put this code actually into the thing itself. So best classifier, blah 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 blah. And I want to do it in here, print and print and put print statement print and just print. I'll put a message there. OPTIM optimal PAOMET or values, optimal parameter settings. So if this is true, it'll run this, and it also put the actual parameter settings. So I can get rid of that now. And the rest of the stuff, and it then I can blah blah. There's nothing else needed here. That's just me outputting the same stuff as before in terms of my classification matrix. So I can get rid of that, and I'll so all I want in here is just naming my classifier. So if that was being used here, so then at this stage here you're going to have a piece of code to picture classifier. So other than that, we can get rid of that rubbish. So I'll get rid of that. So just I leave it here for a moment, but I don't think you need it anymore. Then we'll come down here. I'm actually doing my corresponding grading, so I'll just count these guys out. I'll do my same thing as did before. All that goes in. So now that does nothing if I'm not hyperparameter tuning, and this does nothing if I'm hyperparameter tuning, and this does nothing if I'm hyperparameter tuning. In fact, you can put all that into one cell if you wanted to get it all tied in. So now I've got a situation where I've now got my notebook where I have a flag up at the very, very top that I set for hyperparameter tuning. If it's turned on, it runs the hyperparameter tuning, but it takes a long bloody time. And but I only do it every so often. And once I see the values and that is run, all I do then is I go up and I save those settings in my constructor for my actual classifier. That's basically I have it up there, and then I can turn off my hyperparameter tuning and don't use it anymore. And I might run at the very end one more time, just curiosity, see has it changed. But I honestly don't think it's going to be changing a whole lot. Basically, okay. So that's basically that means I avoid the hyperparameter tuning because it takes a long time. All right. Now at this stage, then, so we have a notebook, and down here, then in terms of my grading, all I'm doing then is I'm picking the when head is my grading. So there's bringing my stuff. And all I'm doing here is when I do my classifying, I pick my classifier I'm going to use to do whatever it is I want to do. So just need to change that and be careful of, I'm using name and model all over the place. So if you're going to be using logistic regression, just specify it in there. Blah, blah, blah. Or say if I want to use the extra tree classifier, all I do is down here, make your predictions. That's the name of the model I want to use. Here I'm applying to my data. Then it's doing my predictions and then saving it out. Okay, so they're the 4 things I wanted to talk to you about, and I ran longer than I planned. It's supposed to be only half an hour. But at this stage now, if I save that, I should be able to run all of this. And just put a message down the bottom. Say MODL done. This should all run. If I click and reset and clear all outputs, run all cells. So what should happen is I shouldn't have any errors. Okay, so the idea being is this: you should do that for both. Oh, sorry, not for both. You should do it for all of your 3 notebooks. For import, you should reset kernel and run all cells. For EDA, the same thing, and for model, the same thing. And that should, excuse me, that should not have any error. Okay, if you do that, then the resulting zip file that this will generate, in the last case in the model, that should be stuff that should all you need to do to upload. Okay, and one small thing, just think about here, when you run those guys, it doesn't actually save the notebook. So the notebook that I get zipped up here, when I run this, the notebooks that appear in that zip file, they may not be the most recent version of your notebook, but as long as you've saved them recently, the change won't be that much. All right, so what might be the only difference is the output might be slightly different. Okay, all right, that's pretty much everything I wanted to say to you guys. Mentioned a few gotchas I mentioned, using the ensemble models, using feature importance to have a sanity check, and avoiding the hyperparameter tuning. And the last thing was the metrics that I should use. I switched that in order, and I did that already. The metric I want you guys to use is just to recall macro metric. All right, I hope all of that made sense. As I said, you don't have to have it all done. You don't have to have the best model done by Saturday. I just want to actually see you have something done and up there, just so I can see what people engage in that. And if there's anybody who hasn't, we can talk about it. We can talk about it. So that's that. Next Monday and next Tuesday, I want to run through the next topic in the notes. So if I'm going to find the page where it has my sorry, actually, I'm at the moment, I'm listening to the Feynman lectures. If anybody wants to, when Feynman went to Australia, he gave 4 lectures on QED. It's very cool. If you've nothing to do, you're unfortunate. Of course, you have nothing to do. Okay. Where the hell is so the stuff I want to do with you next, you can see there, and go back into, bring it back, is the next thing I want to talk to you guys about is I'm going to skip time series mining, and I want to go into text mining, and I'm seeing if I can get an hour done to cover regular expressions and an hour done on covering text mining, in order to get you to start doing this assignment as well, which you're going to have to do. So today is start of week 10, and we have at least until week 15 to get all this stuff done. And I'm happy to give you as much time as possible in terms of spreading it out. So the plan of action would be is I just want to have a sanity check to see how far you're at in this assignment. So and I would probably have 1 or 2 sessions later on this assignment again. One, for example, talking about how actually would you bring in the faculty type is something I would encourage you to have a shot at. As long as you get all the other stuff done first, then we worry about the faculty type. Okay, I'll stop the video here a bit and to upload this, so to be just within the hour, barely. And then the rest of it then, so I'm stopping recording now. And the rest of it is just a Q&A session we'll do without the recording. Stop recording.